Welcome to Unit 1, Level 1 video notes. We will be solving routine one-step arithmetic problems using positive rational numbers such as single-step proportions. Before we begin solving proportions, let's look what a ratio is. A ratio is a comparison of two numbers. If I was comparing this side length to this side length of the triangle, I could write 3 to 4. I could write it with a semicolon, 3 to 4, or I could write it as a fraction, 3 to 4. A scale factor is a number which scales or multiplies some quantity. So if I was wondering how much bigger the triangle was on the right, I can say 3 times what equals 4. And I would solve this by undoing multiplication with division, and I'd be left with my scale factor as 4/3 or 1.3 repeating. That means that this big triangle is 1.3 times bigger than the small triangle. Similarly, I can find the scale factor of what scales this bigger triangle to become smaller. So I can say 4 times what scale factor would equal 3. And if I solve this one, I would divide by 4, and my scale factor would be 3/4 or 0.75. That means this triangle is 0.75 times the size of the bigger one, so it got smaller. A unit rate is how much of something per 1 unit of something else. So this could be like 70 miles per hour, and it's assumed it's dividing by 1 because 70 divided by 1 is itself. So that's 70 miles per 1 unit, so per hour. Or it could be 75 heartbeats per minute, and that would be per 1 minute. Rates are very helpful when it comes to shopping. So if I were buying 15 rolls or 24 rolls of toilet paper for $15, it'd be $15 for 24 rolls. Now I can find out that unit rate by dividing 15 divided by 24 is 0.625, and that would be about 63 cents per 1 roll, because 0.625 divided by 1 is equal to that 15 divided by 24. So if it was $12 for 16 rolls of toilet paper, if I divide that out, I would get 0.75. And anything divided by 1 is itself, so that's really 0.75 per 1 roll. And the better deal would be about 63 cents versus that 75. A proportion are two equal ratios or two equal fractions. So if I have a fraction of 1/2, I can times by 3 to the top and the bottom, and it still keeps that value of 0.5. So that would mean that these are two equal fractions making a proportion. Now, sometimes we have an unknown like up here, and I know that 3 to 4 should be equal to 6 to x. And I can solve for this unknown x by using cross products or cross multiplying. So if I have a fraction equal to a fraction, so if I have a proportion, then the product a times d is equal to the product b times c. So these cross products are equal. So that means if I did 3 times x, that's one product, and that's equal to the other cross product, which is 4 times 6, equaling 24. And we would solve that by dividing by 3 to each side, so x would be equal to 8. If I substitute 8 in for x up here, then I can see if my answers make sense. Well, here I have 3 to 6, so this doubled. Well, 4 to 8, that also doubled. Also earlier we said 3 times 4/3 is equal to 4. Well, 6 times 4/3 is equal to 8. So all of this kind of makes sense. Pretty cool. Let's try that again. So I can solve proportions by cross multiplying. And here's the rule again. If you're given a fraction, then the cross products are equal. So let's do a times d here, which is 3 times 100, 300. And then let's do 20 times t. And instead of writing t times 20, I'm always going to put the variable second. And we're cross multiplying. The cross products are equal, so I can throw an equal sign in there. Now to undo multiplication, whoops, I undo that with division. So I would divide by 20 to the other side, because whatever one you do to one side, you do to the other. And 300 divided by 20 is 15. Now, great mathematicians always ask yourself, does my answer make sense? Now, if I substitute 15 back in for t, my fractions should be equal. My favorite way of checking that is dividing. 0.15. And 15 divided by 100 is also 0.15. So this fraction and this fraction have the same value, making them equal, and equal fractions are a proportion. We're going to finish off level 1 by applying proportions to solve real-world problems. So let's read closely and find out what's important information. The birth rate in the United States is 12 babies born to every 1,000 people. In 2019, the country had a population of about 328 million people. How many babies were born that year? That's what I need to find out. So that's my unknown. How many babies were born? Well, we need to figure that out of this many people. And we know that it's a birth rate. And a rate is like a ratio, a comparison of two things. And we're comparing those 12 babies born to every 1,000 people. So I can write that as 12 to 1,000 with a colon. And that means the same as 12 babies for every 1,000 people. And so that's 12 babies born for like a total of 1,000 people. Well, I'm gonna make that much bigger scale of, instead of 1,000 people, I have 328 million people. And I wanna know how many of those people had babies. The value on the left in the end needs to be the same as the value of the right. So this fraction has to be the same as this fraction in the end. Well, let's use cross products to figure out how many people have babies. So cross products was that A times D, which is 12 times 328 million, and I got 3,936,000,000, and that's equal to the other product, which is 1,000 times X. We undo multiplication with division. So 1,000 times what gives us 3,936,000? Well, we're going to undo that multiplication with division. Sorry, twice. So I know that the people that had babies, anything divided by 1,000 here, those zeros cancel off, or you can just use your calculator, and you get 3,936 people. And that's people that had babies out of 328 million. Now, good mathematicians check our answers. So 3,936 out of 328 million is the same decimal as 12 out of 1,000. So this is 0.12 and this is 0.12 when you divide it out. So our answer makes sense. Good luck on your benchmark and level 1 assignment.